Hello, this is question number 13 in homework 11.1. In a survey, the respondents were asked, would you be willing to pay higher taxes if the tax revenue went directly towards deficit reduction? Treat the respondents as simple random sample of adults. Complete part A to part B. Now here is the data. Let's see the results. This is a little different question because you see how the data is given like males and female and the answer is yes or no. So it's a qualitative question that would you be willing to pay higher taxes? Yes or no answer, two outcomes. And two populations are there, one is female and one is male. So we don't have the given information and how many males and how many females. We just have this, let's look in StatCrunch how it's looking. Big list of male and females just written like that, right? But this is not helpful to us because we need like if we have males, how many sample we took and how many said yes, and then if we have females, how many, what is the size of the sample and how many females said yes. We need that information and that's not given to us, right? So for that you can go to stat and go to table, go to contingency and with data. So in the row, we want the gender, right? Male or female. In the column, we want the response. Did they say yes or no? So let's compute it. So now this information here, this looks way better. So we can note it down. The question is how many females said yes is 25 out of 99, and for the males 30 males 30 males said yes out of 101 males. That data is looking more required. We do not need all this chi-square statistic and all, so ignore that. So go back to the question. What proportion of the males who took the survey is willing to pay higher taxes to reduce the males? So that would be 30 out of 101. And how many females? That would be 25 out of 99. The proportion of females who are willing to pay more taxes. So that is the question, and we can calculate that using our calculator. So 30 out of 101 is for males and 25 out of 99 is for females. So we need to just fill this in our, for the males, this is 0.297. They are asking us to put it in 4 decimal places. So 970, and for females it's 0.2525. Check that answer. Okay, go back to our board. Is there significant evidence to suggest the proportion of males and females who are willing to pay taxes to reduce deficit differ? So here is the test, right? Here is the claim that they are different. So H naught would be that proportions are equal. H1 is always something different. So either different or less or more. In this case, they are asking to test difference. So that is your alternate hypothesis. First, verify the model requirements. Alpha is also given. Alpha is given to be 0.01. What are the requirements? The requirements are that the samples should be independent. Sample size should be less than 5% of the population size. And the B1, right? So we need to check B. So it says N1 times P1 cap. This is P1 cap here. And this is P2 cap here. So we can calculate these values. N1 is 101 times P1 cap is this number here times 1 minus P1 cap is this number here. Close the parenthesis. So you see this number is 21. So that means N1 times P1 cap times 1 minus P1 cap is 21 point something, which is more than 10. We just want to check more than 10. Similarly, you can check that n2 times p2 cap minus 1 to p2 cap is also more than 10. So I'm assuming that they both, you guys can check both of them using calculators. Both of them are coming more than or equal to 10. We're going to say the requirements are verified. Now, the hypothesis, we already wrote the hypothesis. Null hypothesis always equal to type. We are testing if they differ, that means they are just not equal to each other. So that is your alternate hypothesis. Test statistic. Let's use calculator for that. This is a two population proportion test. So two prop z test is what we are going to run. So stat, go to test. 2 prop z test is at number 6. Enter here. X1 is 30. N1 is 101. X2 is 25. N2 is 99. And we are testing the difference, so highlight not equal to and then press calculate. So we have these informations. The z value here is your test statistics. So write that down. For two decimal places, that means we have 70. That should be it. Now they are going to also ask us p-value, which is this p-value here on your calculator. They're asking three decimal places. So we have 0.481 rounding off to the third decimal digit. Okay, now what do we notice? We have alpha is 0.001. Alpha is 0.001 and p-value is 0.481. So p-value is more than alpha. That means what we are gonna do, what are we gonna decide, because p-value is more than alpha? We gonna do not reject h naught. That is what it says. If p-value is more than alpha, we do not reject h naught. That is our decision. Before that, they're asking us to interpret p-value. What is p-value? P-value is if the null hypothesis is true. That means if what is null hypothesis? If the population proportions are equal, one would expect a sample difference proportion in extreme or more extreme. So you remember p-value is the probability of extreme or more extreme when the null hypothesis is true. So one observed in about, so we, how do you get this number is multiply 100 to this 0.48 p-value. So that will be 48 to the closest number. So rounded it off out of the 100 repetition, because this p-value is basically the probability of sample difference coming in extreme or more extreme when the population proportions are equal. Okay, so that is the probability. So out of 148 should be coming like that in extreme or more extreme. Okay, so our conclusion was do not reject H naught. So we have H naught and H1. We are saying do not reject H naught. That means we are going to reject H1. So we are going to say not sufficient evidence. So it's going to be either A or C. And with do not reject, we do not say there is sufficient evidence. We say there is not sufficient evidence at this level of significance to suggest that the proportion of males and females who are willing to pay higher taxes to reduce deficit differ, right? So we are going against the alternate hypothesis. That means we do not have sufficient evidence to support the alternate hypothesis. That should be the correct option. Okay, that is it for question number 13.